Water. Absolutely essential to life. Everyone likes water, especially our judges here today. And with growing communities in developing nations, the demand for more cost-effective and clean solutions in order to purify liquids has become higher than ever. With the cost of ultrasonic wave generation sharply declining due to the advent of new technology, the question is raised, is now the time for ultrasonic wave generation in order to take on a bold new role in water filtration systems? This is Alex Jaeger, Jackson Stobart, Tim Lee, Ashwin Parmar, and myself, Daniel Fisher, and we are Team Ultrasonic Solutions, representing the university and our generous corporate sponsor, Texas Instruments. We have implemented the TI MSP 430 microcontroller with a driving circuit in order to power 2 ultrasonic transducers, which may be used for functions including but not limited to analysis of particles inside of liquids, purification of potentially hazardous particles, and filtration of flowing systems. I'll now cede the floor to Alex so he may demonstrate how we achieve this.
Thank you, Daniel. So our system consists of 2 main components. We have the ultrasonic resonator, which you can see in the top left of the slide. That's a watertight device that's capable of flow, and it also has some viewing windows into the channels between the ultrasonic transducers. It holds the transducers oriented directly at one another in order to create an ultrasonic standing wave, and thereby trap particles in between. And the other component of our system is the driver circuit, and it's battery powered. It has a dual rail boost converter to boost the 5 volts to plus and minus 12. And that plus and minus 12 then biases our op-amp circuit. We have 2 parallel op-amps to get up to 40 volts peak to peak on our 2 megahertz signal. And as you can see on the right, that's our top right is our results. There's very fine lines, ridges of spirulina algae microparticles that are trapped between the transducers. And on the bottom right, we have our time of flight versus concentration. This is like the beginning of composition analysis. And you can test the time of flight from transducer A to B and see how thick the concentration is in the fluid in between. Are there any questions?
Yeah, can you talk about what is currently being used in the industry and how much improvement you need?
There's actually not much used in the industry yet. This is strictly in developmental phases. TI uses the MSP 430 FR6047 to do ultrasonic flow measurements, but those are just at 0 to 3 volts, exciting the transducers. We had to boost up to 40 volts in order to get separation effect.
So are you saying there are nothing being used in the current water filtering techniques and stuff like that?
As far as we've recognized, our project was based off of previous research done at different universities, and they were just doing a system with 1 transducer just to show that you could make the standing waves and trap bacteria in there. So that's the only reference.
So the question, if you trap all this bacteria, what are you going to do with it?
Yeah, exactly.
Where do you put it? How do you get it out?
The main application is going to be composition analysis, where you're not actually trying to get it out. You're just going to concentrate some of the particles there so that you're able to run sort of an analysis on it with frequency sweeps or time of flight measurements, different things like that.
So you're not trying to kill the bacteria or anything like that?
Not yet,
Not yet.
But one day when this technology is a lot further along, that'll be the idea. It will be extraction of either harmful materials or even like precious metals in seawater or something like that.
What part of this project was your own design? It's not clear to me whether the driver circuit design is something that already existed.
That's something that we designed, yeah. We spent most of last semester developing the driver circuit, and we actually made a couple additional changes at the beginning of this semester. But we designed these 2 housing devices. Well, the one on the left we received, but we made modifications to so that we were able to view the effect in the channel. And we printed the other one as well as a couple other earlier prototypes that didn't need to be put on the slide. But
what is the difference between monitoring it or trying to detect the bacteria and actually trapping it? I don't understand.
Well, the trapping may allow for like more analysis. We hadn't gotten to that point yet.
But
but
you trap it where?
So the 2 transducers are oriented into the flow channel here, and it's just basically they're
So it's
suspended.
concentrating it.
Yeah, we're concentrating it in the area between the transducers.
And you can actually measure the concentration by the reflection of by detecting the I guess the impedance of the transducer or something. I'm not sure what you're detecting there, but so you're just eventually you're going to be to a point of concentration that's going to plug up the flow or something.
So
Yeah.
you have a Y there, I mean, it's coming in, it's going out,
Right.
where does it trap now?
It's not actually collecting or diverting it. There are designs where they have a Y, like exactly like you're
Well,
just
what does yours
explaining.
do?
So
We
if
just trap it. That's
It
all we
prevents it
do.
from coming out,
You
So-
trap it where?
right in the
So
middle
if
of the
we-
pipe.
Right in the middle of the
Yeah.
pipe. Yeah.
Yeah,
It
so we-
holds-
Middle
it
of the
holds-
pipe.
It just holds it still there while the water
Okay, I
flows
gotta go
by.
see it, I'll see this.
Yeah, yeah, yeah.
Okay.